Beneath the Geneva gloom, far below the surface of the Earth, lies a stunning triumph of human ingenuity, and an inevitable harbinger of devastation, the Large Hadron Collider, LHC. It stands as an amazing feat of intelligent analysis that allows scientists to probe the subatomic realm, triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This breakthrough has captivated the scientific community. As Brian Cox, a renowned physicist, once ominously declared, a potential hidden from view has been uncovered at CERN, sparking a wave of wonder and worry. Has our quest for knowledge taken us down a dangerous course? Have we chosen a path toward an uncertain future that lies beyond our comprehension? Before delving deeper into this startling statement, it is necessary to take a closer look at the gigantic machine that is the Large Hadron Collider, a CERN facility. The LHC is a massive, 17-mile-wide ring of superconducting magnets. It is by far the most powerful and massive particle accelerator ever developed. A pinnacle of scientific accomplishment, it is capable of recreating circumstances that rival the birth of the universe itself. This extraordinary equipment allows researchers to investigate the fundamental components of the cosmos. But with such immense power, could it lead us to unforeseen consequences, possibly into uncharted and terrifying territory? CERN was established in 1954 and has become one of the world's most prestigious and vital research centers, with 23 member countries and a large network of experts. While the LHC is its most well-known project, it is only one part of an expansive array of accelerators and detectors aimed at comprehending the smallest components of the universe, the very foundation of existence. Protons are sped up to nearly the speed of light, causing them to collide in a course that mimics the energy flow and conditions of the universe at its inception. The temperatures produced are millions of times hotter than the sun's core, while a complex network of magnets directs these particles in their direction of travel. Simultaneously, highly sophisticated cooling techniques maintain the system's supercold environment, far colder than even outer space. The LHC is furnished with 1,232 directional dipole magnets, 392 quadrupole magnets, and special focusing magnets that narrow the beams just before collision. Another important kind of magnet ensures that collisions occur with incredible force. The objective is to collide with such precision that it is akin to hitting two needles 6 miles apart. The level of precision needed for this operation is staggering. The technology involved is unparalleled. Concentric rings are used in the construction, placed deep underground to shield them from radiation's negative effects. To achieve optimal performance, the entire system is cooled to -456 degrees Fahrenheit, colder than any known vacuum in the universe. The underground structure contains 4 distinct particle detectors, ATLAS, CMS, ALICE, and LHCb, each focusing on various aspects of particle physics. Equipped with enormous cameras, these detectors capture particle impacts, with experts constantly analyzing the data in search of traces of the elusive Higgs boson. This particle is thought to be integral to understanding the very fabric of the universe, offering insights into its fundamental structure. In numerous ways, studying the microcosm helps us unravel the macrocosm of the universe, similar to deciphering a massive cryptic jigsaw puzzle. However, with each piece we place, new questions and mysteries emerge, reminding us that every discovery leads to more unknowns. The LHC is not merely a scientific tool. It is an embodiment of human ambition, progress, and the relentless drive to comprehend the fundamental forces that shape our universe. But once we enter the unknown, we must also confront the moral and existential dilemmas that accompany such bold investigation. What are the potential risks of delving so deep? Could our quest for understanding unleash forces beyond our control? In recent months, an unsettling revelation has shaken the scientific community. Brian Cox, a former researcher at CERN and a prominent figure in particle physics, issued a statement that piqued both curiosity and concern. According to Cox, the LHC's goal of recreating a miniature version of the Big Bang, the event that gave birth to our universe, could lead to unforeseen consequences. The collider's impressive ability to probe the Higgs boson and explore the enigma of dark matter, a substance that makes up a significant portion of the universe, could potentially reveal information beyond our comprehension. While the idea of uncovering the universe's deepest mysteries is exhilarating, it is not without risk. The LHC recreates the extreme conditions present at the universe's inception, energies, pressures, and temperatures unlike anything observable in daily life. It's like peering through a window into the very moment the universe began. Such immense power brings with it immense responsibility. Consider the incident involving Russian physicist Anatoly Bugorsky in 1978. While conducting research at a synchrotron in the Institute for High Energy Physics, a tragic accident occurred. A proton beam accidentally pierced his skull, causing significant tissue damage. Yet miraculously, he walked, remaining conscious, to seek treatment. His experience stands as a stark illustration of the potential dangers particle accelerators pose. The power harnessed by these machines should never be underestimated. Concerns about the LHC's ability to form black holes, even on a microscopic scale, have increased among some academic communities. Black holes are regions of space with such intense gravity that not even light can escape. Some scientists have expressed fear that the LHC could produce a miniature black hole capable of theoretically consuming the Earth from the inside. CERN scientists have reassured the public that any black holes generated would evaporate almost instantly and pose no threat to the planet. However, the speculative possibility has sparked both curiosity and fear. The concept of forming a black hole through high-energy particle collisions has been widely debated and has contributed to increased awareness of the risks associated with such powerful experiments. Understanding the mechanics of the LHC is crucial for grasping its potential to form black holes. When protons accelerate almost to the speed of light and collide, the energy produced is so vast that it distorts the very fabric of spacetime. This effect can be likened to jumping on a trampoline and causing the surface to bend and warp. These distortions in spacetime raise unsettling questions. Could such shifts lead to the formation of a black hole? In the bizarre and perplexing world of quantum physics, where the universe's fundamental laws appear to defy logic, there exists a theory suggesting that unidentified aspects of our very fabric of space might conceal the truth. If such components exist, they might be tapped into by the LHC, sparking the creation of a gravitational anomaly capable of forming a black hole. This possibility has drawn attention from some of the world's most prestigious scientists, including the late Stephen Hawking. In his writings, Hawking warned of the potential dangers of the LHC, particularly if the Higgs boson behaves unpredictably at high energy levels. Such an anomaly could trigger a catastrophic event known as vacuum decay, which might not only annihilate Earth but tear apart the very fabric. As we forge ahead in our pursuit of cosmic truths, the Large Hadron Collider remains both a beacon of progress and a subject of profound philosophical debate. It challenges us not only to understand the universe at its most fundamental level, but also to confront the ethical dimensions of such understanding. What are the limits of human curiosity? At what point does the thirst for knowledge begin to tread into realms where consequences become unpredictable, even irreversible? The potential of the LHC is awe-inspiring. It allows us to simulate the earliest moments of the cosmos, delve into dark matter, and test the boundaries of the standard model of physics. Yet, each discovery brings with it new unknowns, questions that unsettle long-held assumptions and stretch the limits of our models. Moreover, the LHC's implications extend far beyond physics. It touches on questions that lie at the intersection of science, philosophy, and even theology. If we can recreate the conditions of the Big Bang, are we, in a sense, stepping into the role of cosmic creators? Does our ability to manipulate the very fabric of the universe raise moral concerns about the scope and limits of our influence? Some argue that the LHC is simply the next logical step in a long lineage of human progress, a powerful but controlled environment where the most advanced minds test the limits of theory. Others remain wary, pointing out that history has shown us the dangers of unchecked technological advancement. It is not fear that should guide our decisions, but wisdom. The LHC stands as a testament to what humanity can achieve when imagination, intellect, and collaboration unite. But it also reminds us that even the most noble pursuits must be tempered by humility. In the end, the Large Hadron Collider is more than a machine buried deep beneath the surface of the Earth. It is a mirror held up to our species, reflecting both our brilliance and our blind spots. It asks not just how much we can discover, but how responsibly we can wield that knowledge. As we peer into the heart of the universe, we must also look inward. For the questions we seek to answer out there may ultimately redefine who we are in here. The opportunity for scientific progress, it offers valuable perspectives on the fundamentals of the universe's nature, but with such a significant moral responsibility comes immense power. We are continuing to discover the secrets of the universe, and we must protect that our quest for information does not come at the expense of our safety or well-being. The LHC is a potent instrument in our attempt to comprehend, but it also serves as a stark illustration of the important moral considerations that come with attempting the uncharted. As humanity pushes the boundaries of knowledge, the LHC's scientific discovery is still an exceptional illustration of our desire to understand the universe. The sheer scale of the project reveals a great deal about the over 10,000 aims behind it. Scientists, engineers, and technicians from all over the world collaborate to ensure the success of the machine, on the scale of the data collected by the LHC. The data is overwhelming, with experiments that produce yearly storage of petabytes of data. The processing power required to handle this colossal quantity of data demands cutting-edge technology that has revolutionized fields like computer science and data science. The experiments at the LHC go far beyond particle physics, extending into areas like materials science, medicine, and environmental studies. The study of the Higgs boson, for example, could have wide-ranging effects beyond our universe's comprehension. The fundamental component of the role that the standard model of particle physics plays is crucial in giving other particles mass. Without the Higgs field, the universe would differ significantly, with particles floating around in an empty, massless state. However, beyond the basic comprehension of the Higgs, scientists are also eager to understand how the particle behaves under extreme conditions. These studies could lead to insights that influence every aspect of the development of new materials and our understanding of the fundamental forces that govern the universe. One of the other critical features of the LHC is its investigation of the invisible substance known as dark matter, which makes up about 27% of the universe's mass energy content. Despite its immense presence, scientists have not yet directly detected dark matter. The LHC's experiments aim to expose the potential components that make up dark matter by observing the behavior of the particles that are made when collisions with high energy occur. If dark matter is finally realized, it might alter the way we perceive the universe, unveiling hidden dimensions of spacetime and changing the fundamentals of modern physics. Alongside dark matter, the LHC is exploring other exotic realms, like supersymmetry and the possible existence of extra dimensions. A theory called supersymmetry makes a relationship between two basic classes of particles, bosons and fermions. This theory predicts the existence of superpartners, particles that have yet to be observed. Supersymmetry could open the door to a fresh perspective on the fundamental forces of nature, providing a deeper understanding of the interactions that control our environment. Furthermore, the LHC plays a crucial role in advancing quantum computing. By understanding the behavior of subatomic particles, scientists can gain insights that have the potential to transform the way we process information. Quantum computers, based on the principles of quantum mechanics, have the potential to solve problems that are currently beyond the reach of classical computers. The technologies created specifically for the LHC's experiments, such as specialized sensors and cutting-edge computing algorithms, have already influenced the field of quantum computing, paving the way for future breakthroughs. Despite its undeniable benefits, the LHC's work also raises fundamental concerns regarding the future of humanity. The search for the unknown can be thrilling, but it also comes with the obligation of taking into account the possible unintended consequences. The very technology that drives the LHC could be used for purposes that could harm humanity, such as in the progression of advanced weapons or creating scenarios that are beyond our control. Ethical debates surrounding the LHC, including but not limited to the possibility of catastrophic events like vacuum decay or black holes, also include the potential applications of the research. How do we ensure that this knowledge is used responsibly, and that the search for truth does not inadvertently result in harm? As we investigate the unknown, it is crucial to engage in ongoing conversations about the balance between scientific progress and ethical responsibility. The global nature of the LHC's work requires the cooperation of multiple countries, each with their own priorities and concerns about transparency in research. Accountability and collaboration between nations will be necessary to ensure that the information gleaned from these experiments benefits humanity as a whole, rather than causing unforeseen damage. The work of CERN through the LHC serves as a reminder that scientific success must always be balanced with careful consideration of its broader consequences. An additional cause for concern is the potential for unforeseen ecological effects. While the LHC is a relatively contained environment devoid of any environmental consequences, the enormous energy requirements of such machines are worth noting, as is the impact on the environment. Particle accelerators, especially those requiring massive amounts of electricity and producing heat, could strain natural resources and ecosystems. The energy demands of the LHC are immense, and although efforts are being made to use renewable energy sources and improve efficiency, the broader question of long-term scientific research must be addressed. Ultimately, the path forward will require careful coordination. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, as with all scientific breakthroughs, ethical consideration and accountability for the dangers involved in such experiments cannot be ignored. But the potential rewards could reshape our understanding of the universe in ways we can only begin to consider. As we move forward on this journey into the unknown, the focus must be on ensuring that scientific progress is carried out in a manner that is safe, responsible, and advantageous for future generations. In conclusion, the Large Hadron Collider is much more than just an instrument for scientific research. It is a symbol of humanity's quest for knowledge and its boundless curiosity about the nature of existence. The questions raised by the LHC's work are profound and carry with them important moral and existential considerations. Additionally, the LHC demonstrates that through cooperation and careful supervision, we can uncover secrets that have the potential to change the course of history. As we stand on the precipice of these new discoveries, we must remain vigilant, mindful of the potential risks, and committed to the ethical use of the knowledge we ultimately discover. The quest for understanding must always be guided by the obligation to protect our future. The LHC is a testament to the power of human collaboration and ingenuity, bringing together a global network of scientists, engineers, and researchers in pursuit of knowledge. The scale of the project and the complexity of the technology it involves are awe-inspiring, but they also remind us of the enormous responsibility that comes with pushing the frontiers of human understanding. As we uncover new dimensions of the universe, it is essential that we do so with an awareness of the ethical implications of our discoveries and their potential consequences. The LHC's experiments challenge our deepest assumptions about the fabric of reality, but the path forward is not without its challenges. There are real concerns about the long-term sustainability of the research, particularly regarding the environmental impact of such large-scale projects. The LHC, as a massive energy-consuming facility, places a significant strain on the environment. While steps are being taken to mitigate its carbon footprint and adopt greener technologies, the broader issue of how scientific endeavors can balance progress with ecological responsibility remains crucial. Moreover, as we venture further into the unknown, the potential for unintended consequences must be carefully considered. The creation of black holes, the possibility of altering the very nature of space-time, or the manipulation of fundamental forces could have unforeseen effects on the world around us. This is why, alongside the scientific breakthroughs, there is a pressing need for a robust ethical framework to govern the use and application of the knowledge gained through such endeavors. Public discourse, policy development, and international agreements will be vital to ensure that the benefits of the LHC's research are shared equitably and responsibly. In the broader context, the LHC's research is just one example of the many ways in which science and technology are reshaping the world. The ethical questions raised by the pursuit of knowledge, especially in fields with such far-reaching implications, are not confined to particle physics alone. Every scientific field faces its own set of moral dilemmas, from artificial intelligence to genetic engineering, climate science to space exploration. It is essential that humanity addresses these challenges with wisdom, foresight, and a sense of collective responsibility. Looking ahead, the LHC will continue to be a beacon of human curiosity and ambition. It will undoubtedly uncover new and unexpected truths about the universe, offering insights that will shape the future of science, technology, and society. However, as we stand on the threshold of these exciting possibilities, we must ensure that we do not lose sight of the bigger picture, the need to act with integrity, care, and respect for the world and the generations that will follow us. In conclusion, the work being done at the LHC represents both the best of human potential and the need for responsible stewardship. It is a reminder that science is not just about advancing knowledge but also about understanding the profound consequences of our actions. The quest for truth, no matter how exciting or transformative, must always be tempered by a commitment to ensuring that our discoveries serve humanity's greater good. The future of scientific progress depends not only on our ability to innovate and explore but on our capacity to protect and nurture the world in which we live.